Ladies and gentlemen, good morning to Australia, good morning to America, good evening to Greece. I want to express my feelings to refer to the promotion of the Greek philosophy in English that deprives the deep knowledge of the spirit of the holy original of wisdom. The divine language is the correspondence of nature to the human mind. The thought comes first, and then the speech, then the writing. That's why I urge all to learn the Greek language. And according to Tolstoy, everyone wants to change the world, but no one wants to change themselves. We continue our 8th lecture of Hellenic education with the 3 Tolstoy's questions. And right now I give the floor to Professor Mr. John Hadjopoulos.
Thank you very much, Coordinator. Welcome to the Hellenic Education Lesson 8. The previous lessons are on YouTube in these links listed here. Lesson 8, we are going to talk about astronomy because Hellenic education includes the study of the astronomy because we are part of the universe and must concentrate our attention to such explorations instead of trying to destroy our planet. In the laboratory, we are going to practice internal and external balance, and Helleni has prepared the story 3 questions by Tolstoy. Here is the summary that Eleni has developed for us. Before we go to the stars, let's start from the Earth, because the Earth is the location that we do all the observations. So the terrestrial or Earth coordinate system that we find our locations, like sigma you see here, is defined by 2 parameters, the longitude, this green arc here, and the latitude, this yellow arc here. Okay. The longitude is measured from the meridian of the Greenwich, and the latitude is measured from the equator, II is the Earth equator, and to the location we are right here. Now imagine that we expand this sphere here, representing Earth, to a radius of infinite, and then we get to the celestial sphere. And let's see how we define the celestial sphere. Assume that the Earth does not move while all the celestial bodies revolve around the Earth in a predictable way, east-west. Essentially, we assume that the terrestrial reference system, together with the celestial bodies, is projected outwards into space, together with all celestial bodies on the celestial sphere, with the center at the center of the Earth and the radius at infinity, as we said earlier. The axis of the Earth's rotation is projected to the celestial sphere north and south, celestial poles, PP. The Earth's equator, II, is projected to the celestial equator. The Greenwich meridian is projected to the celestial prime meridian, G. The celestial sphere, with all celestial bodies on its surface, rotates around the celestial axis, TP, from east to west. Let me get my microphone. Before the GPS, we had to calculate our location on the Earth using astronomical observations. And that was developed the geodetic astronomy. Actually, I have taken so many courses on geodetic astronomy. I would say about 4 courses here in Greece and 1 in the United States. So we can calculate ground coordinates, the longitude, latitude, and azimuth. And we use 2 celestial coordinate systems, the equatorial and the horizon coordinate system. In the celestial sphere, as we said, we assume that the Earth is not moving. It's just like the geocentric system. We do that because we have to find out the location of the celestial bodies relative to the Earth. With this assumption, it is very easy to do it. And therefore, the celestial sphere moves from east to west, rotates around the celestial poles, as you can see here. And the sun, however, and all the stars, etc., they move as the celestial sphere rotates from east to the west. They rise from the east, they go to the west. The sun, though, does one more movement, and this is called ecliptic, you see here, which is the movement that the Earth does around the sun. But because we say here the Earth is not moving, the sun is moving. So in 24 hours, the celestial sphere makes 1 rotation around the celestial polar axis. The sun in 1 year makes rotation through the ecliptic. The ecliptic cuts the celestial equator in 2 points, the vernal equinox or gamma point, and the autumnal equinox or gamma prime, you can see here. These 2 points are fixed points on the celestial sphere. They do not move. Of course, they move with the rotation of the celestial sphere, but they are fixed in this location. Also, the ecliptic, which is the rotation of the sun around in 1 year around the celestial sphere, has an angle with the plane of the equator, 23 degrees, 27 minutes. You can see here. And the lowest part of the ecliptic is the winter solstice, and the highest part is the summer solstice, you can see here. There are several things to consider now, parameters we use in the celestial sphere. First of all, any circle passing through the poles and the celestial body is called the hour circle of the celestial body, you can see here. And the angle of the hour circle of the celestial body and certain other, say, reference circles like the Greenwich hour circle, the local hour circle, and the gamma hour circle here define these so-called hour angles. Hour angles, they are measured clockwise, as you can see here. Also in a point, if you take the plumb line upwards, cuts the celestial sphere in the zenith point, and downwards to the nadir point. And each location on the Earth has different zenith and nadir point. A circle perpendicular to the rotation of the Earth axis is a parallel circle, as you can see here. Again, we are going to talk about 2 coordinate systems in the celestial sphere. There are more, like the ecliptic, the galactic, and the supergalactic system also. But we are interested just in our solar system, and we use these 2 systems. The equatorial reference system defines any celestial body with two parameters. The hour angle H of the star, which is the angle clockwise from the vernal of the hour circle of the vernal of equinox, and the right ascension, which is the same like our angle, but it's measured counterclockwise from the vernal of equinox to the star. Of course, these two angles are about the same. The other angle, the second parameter, is the declination of the star, which is the angle from the celestial equator to the star. These two angles we can see here in this figure. Okay, this is the north celestial pole, and this is the celestial equator, the blue plane. And this is the right ascension. You see, right ascension is counterclockwise. Our angle is clockwise to the star, is this one. Okay, this is the declination to the star. This right ascension and declination, they are constant. They need some small corrections because of the problems the axis of rotation here of the celestial sphere has. We are going to talk about it. But there are tables that give us these corrections. And therefore, any star can be defined by these two parameters, which are more than less constant. Their change through the time is very small. The second coordinate system uses the azimuth and the altitude. And you can see here, if we assume here is the observer and here is the plumb line through the observer defines the zenith and nadir point down here. Then if we have a star, the arc above the horizon is a plane perpendicular to the vertical line, okay, is the horizon. The arc over the horizon to the star here is the altitude of the star. Usually in our measurements, if we use a theodolite, we measure the altitude of the star and the time. And that's how we can do some calculations later on. Also, we have here the azimuth measured from north to the vertical circle. Any circle passing through the zenith, nadir, and the celestial body is called a vertical circle. Okay, so from the north to the vertical circle, we have the azimuth clockwise. Okay. Also here, this circle you see here is the prime vertical. Prime vertical is the circle that has the zenith and the north and south celestial poles. So somewhere on this circle here to this one is the north and south poles. It's called the prime vertical. Where the prime vertical cuts the horizon, okay, defines the 4 points of the horizon, like east, west, you see here, and north, south, right here. Here is are summarized the two coordinate systems, horizontal and equatorial. Now let's go into our planet system. Our planet system, you see the sun at the center, the Mercury, Venus, and the planets around the sun. The way the distances from the sun now follow the golden number 5, you see here 1.618. And if we assume that Mercury, the distance from Mercury to the sun is 1, then the distance from Venus to the sun is 1 multiplied by 5, by this number. The Earth by 5 square, and so forth. We must say that the fifth orbit here was a planet that probably was exploded, and we have the asteroids there. Also, we may see the comets And this is our solar system. There are a couple of laws regarding the orbits of the planets around the sun. And here are the Newton laws. And I'm going to focus on the gravity, which is inverse proportional to the square of the distance between two masses, M1 and M2, you can see here. And also the acceleration and the reaction force. Okay, in every force, there is an equal and opposite reaction force. Then we have the Kepler's laws that the orbits of the planets are ellipses with the sun at one focus of the ellipse, you can see here. And you have to understand also the orbits in equal time, they write equal areas. And to do so, they have to move faster when they are close to the sun and slower when they are away from the sun. Of course, it is obvious that when they are close to the sun, the attraction forces, because of the gravity, they are higher. So they have to move faster in order to balance with the centrifugal force, the gravity force, okay? And that is done with the Kepler's law of equal areas. Let's take a look also at the zodiacal circle that the Earth is being around the sun, being in several locations. For instance, on May 21, the sun is projected to this asterism here, which is the Taurus, okay? On February 21, like the Earth is here, so the sun is projected to the Aquarius. And that's how the orbit of the Earth around the sun creates the various zodiac we know about. Also, this is interesting. As we said, the axis of the Earth to the equatorial plane cuts into an angle, is not perpendicular, it is in an angle. And that gives the opportunity for the North Hemisphere, which is here summer, winter time, to be closer to the sun. So we have, say, better winters than the South Hemisphere, which is here, okay? When we have summer, the South Hemisphere has winter, is away from the sun. And summertime, we are away from the sun, but the sun comes, the light rays from the sun come into more perpendicular way to the surface of the Earth. Okay, over here, winter, they come into an angle. That's the reason we have winter. Now the time, we have various ways to measure the time. Is the sidereal time that is defined by the hour angle of the vernal equinox. And then we have the solar time with all these ways, different ways to measure it. The reason we have all these different ways is because, as we said, because the sun doesn't move with the same speed all the time. It has different speeds. And as we said, the Earth around the sun has different speeds, doesn't have the same speed. But the clocks we use, they have the same speed. So in order to balance this difference, what we do is we put a fictitious sun on the equator that moves with constant speed, okay, and we call it mean solar time, okay? And that's how comes the universal time coordinator or universal time in here. But the true solar time is based on the apparent motion of the sun. And therefore, the difference between the true solar time and the fictitious sun we put to adjust our clocks, okay, it's called the equation of time. Now, in order also to work in an area like a country or a widened area with the same clock time, we have the zones around the Earth that they have. Each zone has a constant time. And here are the zones around the Earth. They start from the Greenwich zone. For instance, Greece has 2 hours difference. And the Eastern United States, they have, I think, 5-hour difference. Okay. You can see that.
Okay, 5, yeah.
Now, the time works in order to be able to keep it somehow constant. We have to have some reference clock working and doing that. And this is an atomic time with the cesium-133 that does that. And also the sidereal time, which is the our angle of gamma. Gamma is a fixed point on the celestial sphere. So in 1 year has 24 hours about difference with the solar time, because the sun also moves around the ecliptic, okay? And also we have as a reference time for the solar system, the sidereal time. And there are links in the internet calculators that if you use your, you put there your longitude, they give you all this sidereal time and whatever else you want to calculate. We said about the axis of the Earth that is not, does not maintain a constant direction, okay? It has the so-called precession and nutation. This is precession and nutation. And this is, there are very small movements, but we need to do the corrections. And as I said, there are tables that gives us the corrections for a particular time period. Now, we have different ways now to use the time from, go for instance, from the local mean time, that whatever the our clocks show, to go and calculate the local sidereal time, or the right assess the local star time, etc. And also do some other calculations, like if we want to determine this way the longitude and the latitude on the location on the Earth and the azimuth. We can do also calculations like that with the time. The mean sun, we said, is a fictitious sun created by uniform stellar motion at the equator, and the clocks are synchronized with it. The difference between the real sun and the fictitious sun is the equation of time. Of course, we have to understand that the real sun, the time starts from noon, at noon, 12 at noon, and the time we measure on the clocks, they start from midnight. So they have a 12 hours difference that we have to take into consideration also. And the universal time coordinated, okay, is the time, the Greenwich time. Now over here is the equation of time that is given from day 0 to 365, okay, through the year. You see the minimum is minus, how to say, 15 minutes, and the maximum is about 18 minutes, as you can see here in this diagram. Over here also is given the, say the Greenwich meridian is this one, and this one is a location on the Earth with 90 degrees longitude. And in this way, you can see what we call local apparent time. This is the apparent sun, this is the mean sun. Okay, this is the local mean time. And we have the Greenwich mean time and the Greenwich apparent time. Okay, the Greenwich mean time is this one. This is the Greenwich apparent time. If we want to calculate the hour angle of the local hour angle of the star, probably if we want to observe a star, okay, then we can use the local time you see here to transfer to the Greenwich time, and this is the time zone, and this is the daylight savings time. This is summer time, and this is the right ascension of the star. 12 hours difference. We said this is the equation of time if we use the sun. This is the longitude of the place and the right ascension of the star we want to calculate the hour angle. And this is how we do it with this formula. Of course, there are calculators, they do it for us. Okay, just you put the longitude here and the time, okay, and then it gives you all these values we said earlier. Right ascension. This is for the sun, Julian date, mean sidereal time, you can see here. Equation of time, okay, it gives you all the values automatically. This is the internet address to get there. Now, if you are in a location, you don't have GPS, you have nothing, you want to get your orientation in North Hemisphere, this is the Polaris. You can find it from the Ursa Major. It looks like a pot, okay, in the kitchen pot. And you project these two stars, you project it and you get a star alone. In this location is the North Star or Polaris. And this is also on the right, Cassiopeia. The other stars of the Ursa Minor, they don't appear to be too bright, but the Polaris is brighter than all of this and around this neighborhood. We can make the measurements and calculations. Actually, the measurements we do is we measure with the theodolite the altitude of the star and the azimuth and the time. These three things is what we measure. And then we can do calculations using the so-called PCS triangle. This is the pole, the zenith of the place, and this is the celestial body. And solving this triangle, we can determine like the longitude, latitude, azimuth, and whatever else we want to measure here. This is from spherical trigonometry, how we solve the spherical triangle. Actually, we have with small letters the arcs, and with large letters the angles, okay? And this is another more complicated way to find out where is the PCS triangle. Okay, this is the celestial pole, North Pole. This is the zenith of this location on the Earth, okay? And this is the prime meridian that passes through the pole and the zenith. This is the prime meridian of this location here. Actually, any celestial body crossing this observer's prime meridian, okay, then this celestial body is in culmination, is in the highest altitude above the horizon. And over here, usually we measure, as I said, okay, you can see this is the observer's horizon. So the star above the horizon, this one is the altitude of the star, okay? And then we have the time is related to this, our angle of this star with the time, when we record the time at the moment of the observation, we can calculate this T angle here. And then if we know the altitude, also we know the declination of the star. We said that this is known from the tables, okay, the astronomical ephemerides, they are called. And if we can calculate the latitude or the longitude if we know all this, we do all these measurements. Of course, there are other measurements that we measure one or more stars at the moment of culmination, etc., that simplifies things, or we make observations on the sun and the Polaris to get our location on the Earth, but we are not going to go into more detail on that. Okay, this is how we calculate the azimuth by observations on the Polaris. And what we measure actually here is only the altitude of the actually we measure the time, we measure the observation and the altitude of the Polaris. Also, what we calculate, if we calculate the longitude, the latitude of the place, this is the astronomical longitude, latitude, which do not have much difference with the geodetic or geographic latitude, longitude here. Okay. The difference, the geographic is on the surface on the Earth, the other are on the celestial sphere. And on the surface of the Earth, we have different other considerations like the ellipsoidal parameters of the shape of the Earth. Or if we go into projections, we have the projection parameters. This is the way we can measure the, when we do observations on the Polaris, how we can calculate the azimuth, precisely the astronomical azimuth on the Earth. And this is the end of the lecture in the astronomy. Just I put this transparency because last time we had the question about regarding we are sure that virtue with the internal and external balance can be taught and make a difference to young fellows. And I gave this example. How come, like the media, they convince these young fellows that having this situation in their pants, they are beautiful. They have the sense of the beautiful. And of course, it is much easier to convince them that they will have quality in life if they follow the internal and external balance. Thank you very much.
Okay. I have something to say practically. I will refer to the horizon, to azimuth, which is the right angle formed between the north and the point intended by the compass, i.e. a practical means that we use for our orientation. To achieve this, we turn the pointer in the direction of the point we want to determine the location. Of course, in place with magnetic fields, it is not accurate. As in America, for example, while in Greece, there is no magnetic field to be affected. We turn the windshield of the compass so that the magnetic needle coincides with the north, of the windshield, and we read on the windshield the indication in degrees given to us by the base of the pointer. The windmill has the cycle and the circumference of 360 degrees in 4 equal points of 90 degrees, which is 0, and always coincides the north with the 360 degrees, that is the Tramontana. The opposite point of the south of the 180 degrees is the Austria on the right, and in the middle between the north and the south in the 90 is Levantes, or it is called the Apiliotis also. Another line called Zephyros, the 4 lines that determine the direction of the winds based on the windmill, and this is the practical method for azimuth. Now, recording the terrestrial reference system, the equator, which is the greatest imaginary cycle, and we can bring it around the Earth, and the parallels of the latitude that are above and below it and are infinite. For each place, there is a parallel only. In other words, such imaginary cycles, we can bring myriads. And as you said, they are the meridians. We observe that all these meridians necessarily pass through the point P and P. On the thing you have shown us. That is from the north and south, and the meridians necessarily pass from there. Its distance from the parallels show that the shape with F to show that this is the cycle of latitude, while the distance of the imaginary line is shape L, is the longitude. And now we go to the celestial dome. Can you show us the celestial dome, Professor? Did you find? No. Okay, that's the same, okay. And the zodiacs, the months. Yeah. Anyhow, we keep in our mind the shape of the months. If you can find it now, I continue.
The zodiac slide.
Anyhow.
This is it.
Okay. As I said, in the annual motion of the Earth, where you presented us the months of the zodiac signs, besides these, there are other constellations that we use for our orientation, especially when we meet at night with the pole star. We can find where the north is, and then we find easily south, east, and west. Based on the Big Bear, which has the Algor, second in line, the one that astrologers observed and tasted the acumen of their vision. That's why it is called a tester. The little bear, the Arcturus, as we called, Hercules, Pegasus, fed on flames and much more. This is encyclopedia now knowledge, and Cassiope, which has a great role in our orientation. The great constellation of the dog has the glittering Sirius on its left, Orion, which rises in the autumn and mid-winter and sets in spring, and in the fantastic square between that imagined square, the three kings who represent the three Christmas magicians. That's all. Thank you.
Coordinator. And I think we must give the floor to Helen to...
Very interesting comments from the coordinator. May I ask a question?
Yes.
Yes. I have a question about, you know, all of this is very complex information, but you use the word time many times. And I have a question about time. It's probably a simplistic question, but I would like your feedback. So, in the calculation of time, as we calculate time, is it dependent on the distance from the sun, on speed, movement, the speed of movement, or any other factors? Or is time a concept which is static? I mean, can you shed some light on what chronos, what time is?
Yes.
Thank you. Thank you.
Actually, what we define as time is something that is related to our problems and how to cover our needs. And to cover our needs is the clock time that considers that the sun goes or is on the equator and goes on the same speed and in 24 hours makes a full rotation around the Earth. From east to west against to east.
So time, what you're saying is time, the way we calculate time is simply a convenient way for human beings.
That's right.
To describe their own activities.
That's right. Then we have time that we need in the scientific area, that we have to see the stars, the sun, how they were 1,000 years ago and how they are today, and what changes we have, so that the time is, and we have all these GPS and all these things. So GPS has its own time also, how it starts and how it functions. But scientifically, we have the so-called Julian day, which starts 0 something, I think. I think somewhere in the transparencies I mentioned that some a few thousand years ago starts, and it's up to date, the Julian date. Then we have the real time, the universe time, that probably started when the Big Bang took place. Okay, and probably this is the best time, because in the next lecture, I'm going to talk about that.
Okay.
when this happens, you know, then the ether starts moving in a spiral way, and for creating this movement, the wave moving, say, particles create this time. But also we have a clock to measure the time, so we don't lose it. Okay, and this is the atomic clocks I told you, that they have this standard frequency. Usually we started with the crystals like the quartz, most of the clocks they have, okay? And because they have a constant frequency, but it's not exactly constant. So the atomic clock has more than less constant frequency. That's the reason they use it to have it as a reference. So we don't lose seconds or fraction of seconds through the years. Okay, it's not a simple thing, as you see. It's really complicated.
Very much so. Thank you, thank you. Am I next?
Yes, you are.
Okay.
And thank you, the coordinator, because you complimentary, you know, help my lecture.
Okay, so share my screen. Can you see my
yes,
presentation? Is my presentation visible to everybody?
Yes.
Thank you. Thank you. Thank you. Okay. Well, it's difficult for me to make a transition from Professor Hatzopoulos' summary overview of time, of geopositioning, of the very complex matters that he discusses, to Tolstoy's The Three Questions. It seems on the surface that we are going from something very complicated to something very simple, but I'm not sure about that. Not sure about anything anymore, especially since we've started including Plato and Aristotle into the equation, who, by the way, Tolstoy was an avid reader of, as well as Rousseau, as well as many philosophers. So the Three Questions, I hope you had a chance to read the short story before class today. It was published as part of what Tolstoy wrote in the last part of his life. His great novels, War and Peace, Anna Karenina, etc., were written in the first part of his life. But as he grew older, there came a time when he rejected, I would say, rejected many of the preconceptions that he lived under for most of his life. And he wrote many short stories and essays that reflected a turn to the simple. He was very interested in education. That's a very important part of Tolstoy. Very interested in bringing the great ideas down to a simpler level for the, as he called, the common man, the peasant, those who are not intellectually stimulated, let's say, those who don't necessarily go to the university and study Jean-Paul Sartre, etc., existentialism and all of the rest. But he felt that in the simple stories that he wrote, that the greater universal truths could be found. So I can stop there as we get into this. So that's Tolstoy. Who was Tolstoy? Tolstoy was a Russian nobleman born into a very aristocratic family. He led his younger years, his youthful life was spent in enjoyment and dissolution. He traveled to Europe. He came back, and I think most people will agree that a great turning point in his life was his service in the Crimean War, a particularly violent, horrible episode in the history of Russia when Russia was attacked by the great powers at the time, including the Ottoman Empire. It was a long war. It was vicious. Tolstoy saw battle, and when he came back, he was changed. He got married. A great love affair between himself and Sophia, and produced, I believe it was 13 children over the years. He had 13 children, 8 of whom survived childhood. Established a great family. Unfortunately, some of his property was sold off to pay gambling debts. He was a very well-rounded figure. He was interested in philosophy. He was interested in the daily pleasures of life. And he was interested also in his immortality, I think, as the years went by. We can say that for most people, I would say. Let's go to the three questions. And I think that one of the key factors that Tolstoy was interested in terms of his life, in terms of his work, were the unknowns. And I found this quote. I think it describes Tolstoy very well. Someone once said there are known knowns, there are known unknowns, and there are also unknown unknowns. We all understand that. And then Tolstoy would have added this. He would have said that there are unknown knowns. Very metaphysical statement, but he was a metaphysical man in his writings. And I have a few examples here for the class, for anybody who's watching. Example of known knowns, recorded documents, dates, artifacts. We can only observe, but we can only observe them in the past. Examples of known unknowns, myriad. Here is where inquiry, for example, in your field, Dr. Hazopoulos, science, the whole espionage field makes its attempts. And then the unknown knowns would be where Tolstoy, I think, is trying to find out, trying to understand what we mean by that, just as Plato and Aristotle and the great Greek philosophers were doing 2,500 years before him. So what is the conflict in the three questions? The conflict arises because the experts the Tsar first consults cannot fathom that we can only observe the past and that randomness rules the past, thus making future activity impossible to determine. So the past and the future are impossible to determine. They're not living as a community, are divided into too many factions, have preconceived notions about the workings of the world, are too overconfident about their ignorance, using their time on earth for self-promotion. Unlike the Tsar, they are not on the path to self-transcendence. Now we're talking about the experts, the people that he first consulted, the Tsar. They're not on the path of self-transcendence, not even receptive to each other. Instead of imparting wisdom, or at least knowledge to the king, they highlight their confusion about life, self-contradictory, not self-reflective, ignorant in the matter of the utmost importance, how to be a good human being in life. Now, of course, the Tsar did not ask he did not ask the learned men how to be a good human. He had specific questions about, that he asked. And here are the questions. When is the right time for every action? Who are the right people to listen to? And what is the most important thing to do? So he was convinced that if he would succeed in any endeavor, if he possessed the answers to these three questions. So in order to do that, he asked the advice from the most educated in his kingdom. After hearing the answers, the king decided he would approach a hermit, widely known for his wisdom. And I think we know what a hermit is, but just to recapitulate the definition of a hermit in terms of in the context of Russian society and many other societies as well. A hermit is a man usually, but there are also women, men who live away from the social interactions of communities, live close to nature, and commune with God. Many countries have their own versions of hermits. Native Americans, Asian, Indian, the gurus, etc. Although the gurus end up having followers. In fact, some of the hermits in Russian times also have their followers after they've established monasteries, etc. Anyways, not to get off the point. So in order to approach the hermit, which is interesting, the king dressed in plain clothes, he dismissed his bodyguards, and he met the wise man alone. This tells us something, I think, about the king. The king already has a very important, he already has an understanding of his place, of his position in terms of the hermit. He's not going to the hermit dressed in his royal finery with all of his soldiers and all of his followers, but he is either I think possibly cleverly doing so in order to be able to approach the hermit. He has a sense of submissiveness. He has a sense of his unworthiness as a human being. He's not possessed of this, of some kind of a royal importance. So that's important to note, I think. Let's continue. I'm just going to go a little bit faster. There are three quotes from the story. So the first lesson, I would say, the episode, treat others how you want to be treated. And in the text, the example is, you are tired, let me take the spade and work a while for you. Can anybody in the class tell me who said that? Who said you are
Kermit tell that.
Yes, the king said that, exactly.
The king said to the Kermit.
To the hermit. Okay, the second episode. Live in the moment, not in the past or future. The example in the text, when the man ran into us, the most important time was when you were attending him. If you had not bound up his wounds, he would have died without making peace with you. Without making peace with you. Who said that? Anybody?
The wounded man said that.
The hermit said that. The hermit said that. You were sent here to do good for the world. Example, the most important thing to do is to do good. Who said that?
The hermit.
The hermit again. Okay. Very good, class. I'm glad you read the short story. A little bit, just a little bit also about the way that Tolstoy writes the story. His characters are both dynamic and static. The hermit is a dynamic character in one sense. He stays true to his beliefs throughout the story. Now, some people say that, well, if he doesn't change, if the hermit is not changing, how is that dynamic? Maybe we can talk about that in a short time. The Tsar, the emperor, the king, is both dynamic and static. He wants the answers to receive enlightenment. The hermit helps the Tsar realize the answers, thus saving a wounded man. He is also static because the three questions he poses prevents him from realizing that he was living by the answers without knowing the answers. So he's actually a static because he is innately the qualities that he is seeking, he already possesses, but unknowingly, he doesn't know that he has these qualities. The assassin, the wounded man, is also a dynamic character. I think a purely dynamic character. I was sent to kill you, and you saved my life. Well, we know that the assassin had reasons for trying to kill the king. The king had killed the assassin's brother and taken all of his property. The assassin was very angry. He was seeking revenge. And yet, by the king attending to him and saving his life, he changes. So in that sense, he is a dynamic character. He changes. But can anybody tell me before we go on now, why do we say that the hermit is a dynamic character instead of static?
Perhaps because he didn't give the answers the first time to the king. And then after the wounded came, then he gave the answers.
Wonderful.
He left to come the right time. He left it to answer when the right time came.
This is wonderful. Absolutely. Yes, absolutely. He is dynamic because he doesn't follow the rules of discourse, let's say. He doesn't answer a question when the question is asked, but he does something maybe Socrates would do. He would, or any of the Greek philosophers, he would be patient and he would give examples. He would give parables. He would ask other questions. Or in the case of the hermit, he would be silent and wait and see what the king would do. That takes a lot of energy. And so we say that we can say very, very easily that the hermit is a dynamic character. Okay, let me go further a little bit. I think because of time, because all of the slides here are self-descriptive, and we can talk about them, but because of time, I think we should go to our final homework slide at this point. We haven't really talked about the relationship between the Greek philosophers and Tolstoy, or the hermit and the king and the characters, but we can do so now. We've had enough background in the last 8 lessons that we can talk about it a little bit better. Thank you, Professor Hatzopoulos, for sending your homework ahead of time. And for anybody who's listening on Facebook, any students, I would request that for next week, please send your ideas beforehand, if possible. Okay, so let's take a look at the Tsar. I changed this because I think it's important to take into consideration what the class members say. You have divided the Tsar into before and after. Now, I wouldn't have done that, but I think it's very clever and it's very insightful what you have done. The Tsar before, you say, Dr. Hatzopoulos, is confused and is not internally balanced. I'm not sure why you say he's confused. I think you're saying he's confused because he is asking so many people for the answers to his questions. He's not able to self-reflect at this time. Is that what you mean by confused?
Yes, he does not know the answers to his questions.
But he
doesn't know, or he is not aware that he doesn't know?
Either way is that's the confusion.
Okay, all right. But you see, the problem that I have with that, and I'm not disagreeing with you, but the problem that I have with the word, maybe it's the word confused, is that how does Plato understand self-actualization or self-realization? I mean, I remember the allegory of the cave. It seems to me that it's impossible for some people to ever come to an understanding of reality, or understanding reality, outward reality, without understanding their own reality themselves, within themselves. But I don't consider that to be confusing, but maybe we're just playing with words. It's okay. We don't have to worry about that. Okay, after the meeting with the hermit, the Tsar has internal balance, and he finds internal balance by seeking answers. So in the search for answers, he becomes balanced.
Yes, because he used his logic to balance the desire and anger there.
Now I understand.
The moment he uses logic, then he's in balance.
Now I understand. By not listening to all of these learned wise men, he has an internal logic which tells him that he needs to continue his search for the answers.
Yeah,
I see.
Doesn't have answers. He acts without answers before that.
Okay, now Aristotle. He's out of balance. He's created enemies, and we know that because of the assassin.
No, we are talking about actions. When we go to Aristotle, we talk about efficient logic. And when we go to Aristotle, we are talking about actions.
We're talking about actions.
Yeah,
mm-hmm.
Actions are to balance because creating enemies.
Yes, that's a good way. Creating enemies, exactly, would be creating enemies would be a sign of being out of balance. Exactly. Okay, I see what you're saying. And the consequences, of course, victims because of that, enemies threatening his life. And then you have another comment also, never too late to become a virtuous person. Exactly, okay. Afterwards, and he sought the answers. He has external balance by acting to find answers. And you know, I have a question as well for anybody here in the class. What does the Tsar do, the king? What does the king do, though, how does he find the answers? How is it that he finds the answers? Does he find the answers by his own initiative, by his own reasoning, by his own logic? Or does he come to the realization because the hermit teaches him, tells him what he needs to know? I find this a little bit difficult to understand when I mean, I understand the story, but I find it a little bit difficult to understand this part of your answer.
It's very simple to me because everything starts from the efficient logic again. The efficient logic says that something goes wrong in your kingdom. You have to, something you are doing wrong. Mm-hmm. You have to find the ways to correct it. And he raises these three questions. Then with his logic, the moment he sees that all these around him advisors, they do not satisfy, they do not give satisfying answers, he goes to the hermit. So he tries to find the best, the optimum way to get the answers. And he tries everything. He has and the best thing is to go to the hermit. And when he finds the answers there, then he changes his actions because Aristotle is actions. And he does both. He has internal balance and external balance because he corrects his errors, the degree he could correct it.
Yes, please. Yeah.
I think that the answers were not given by the king, but the hermit gave the answer up to the time that the king was waiting the answers. The hermit explained to the king what was the right time for each question. And then the king understood what the three questions were. So I can say that the three questions were given by the hermit to the king, and the king understood the meaning, and then we find the external balance of Aristotle.
So
I think that's my opinion.
Yes, that's wonderful. Absolutely. I think what you're saying is there's a symbiosis between the activity, the actions of the king in following what he's not following what the hermit is telling him to do. He is doing it of his own will, of his own free will, of his own volition. In terms of the end, though, the realization of what the answers to his questions are, he's still not sure until the hermit tells him. But he realizes that through his actions, he knows the answers, which leads me to my final point. How is that? How can this short story and this relationship between the hermit and the king be used in reforming education? Since I know this is one of the purposes of the course, can we discuss this now or another time?
Yes, well, there never is too late to become a virtuous person covers that, because the moment someone understands the mistakes that does, okay, then from there on has to have efficient logic to find a way how to correct the mistakes. And this is all the idea of internal balance, to have efficient logic when something goes wrong, to see how to correct it. And this is what the king does. And this is how he got the optimum, I would say, way through the hermit to get these answers and find his way and correct his errors. This is education, internal balance, efficient logic. And then if you see your mistakes, your bad things, you can start correcting them and do the external balance.
I understand what you're saying and I agree with you. However, pragmatically speaking, I'm not sure that the real world that we live in is filled with people who are willing to learn, like the king, and people like the hermit who are wise enough to be able to allow the student the knowledge. So this is where I'm trying to understand how do we bring this situation here from the three questions into our classrooms today. But we can let me continue here. I had one more. Maybe I can't. I think it's difficult to find it because my slide is too big. Let me make it smaller if I can. I had one more question, and then maybe I can't. I had a question about the other characters, but that's okay. I can't, I'm not able to, maybe I can, no, I can't do it. That's okay. Well, that's all I have. I wanted to ask a question about the learned men, the people that the Tsar first sought out for answers, and how you would place them into this chart. That's what I was hoping to do here, but I can't find my learned men. Here, I think I can find them now. Here we go. Yeah, here we go. Okay, the learned men. Because we know our world today is governed by these experts. We have so many experts advising us, advising our leaders what to do. I think they're out of balance. I think everything about these people is out of balance, personally.
Yeah, well, the world today is governed by the markets.
Okay.
It's out of the human the governance of this world is not taking into account the human beings. It's the markets. That's what it is. They tell us officially.
So what can we say? Let's cancel these people out. We'll just cancel them out because they don't exist in this ideal world. They cannot. They're living in another. They're existing for other purposes. For, as you said, the market.
Yeah, that's right. That's what they say all the time. And we have, as humans, if we have free will, if we have sufficient logic, to see this thing and try to correct it.
So the education system, which operates at the market level, it certainly operates with under the control of the market. How do we change that?
With this effort we do in this class.
Okay, that's what I thought you would say.
This is the way. There's no other way.
This is the meaning of the lectures, to find the way how to go through and know the philosophy as it appears wise.
To solve our problems.
Well, I have nothing else to say at this point.
Yes, I have something to say.
Good.
Well, for me, the right moment that proves the internal balance of virtue was the disguise of the king to have the answer from the hermit. The second is the willingness of the hermit to rest in digging. An internal balance, the fact that the hermit did not give the answer and waited at the right time, at that right moment. This shows the external balance of virtue, because it would be understood by the king in practice, in the right moment. The answers will be given at the right time and would be understood by the king. So, having the internal balance, the king treated his enemy with the result that the wounded man felt the transcendence of goodness, and his friendship was accepted by the king and by enemies to become companions in their lives later. So this is an internal balance, really, because enemies and king became friends. And not only friends, but the king took his enemy to his to his house anyhow, and live with him. It means that the internal balance worked normally and logically. That's all. Thank you.
May I ask you quickly, what you had a comment about the assassin, the wounded man. What did you say about him? I missed it.
Yeah, it was before he was wounded and after. Before he was out of balance, internal, to go, through revenge and kill the king. And out of external balance, also trying to act like that, and the consequence was to be wounded. But after he was treated by the king, he did have efficient logic to understand that the king saved his life, so it's not bad to kill him. So, and he turned out to be to help the king, whatever he could service he was able to do, and he became a friend.
He that's a quality of pride that he had. What is the mid-space? What is the mid-space of pride? I know there's extremes. There's pride, there's humility, and I think so he at first he is the wounded man is filled with pride, which is a negative. He's out of balance because of his pride. So he regains his, you would say he regains his what? His humility?
Efficient logic.
Efficient logic, okay.
Yeah.
And then under Aristotle, it would be, he regains a sense of,
he became a friend of king under Aristotle.
Right, exactly. Good. Okay, thank you. Thank you so much. I wanted to clarify that. Thank you so much to both of you, to everybody for the inter exchange. And I will send the revised PowerPoint to all. Thank you.
I also want to thank you, Helen, because you were wonderful in all the aspects of the laboratory coordination. And also Dimitris was excellent in his job. And I want to listen to Petros. And I don't see him.
Petros has left.
Petros has left.
But I want to congratulate Helen because she prepared the laboratory so well, and the whole story she explained. She made the questions to us. She wanted to deep to the story, and this is a very good thing because we try to find the truth, to find the logic and philosophy in logical way. Thank you very much. I think we're
very kind. Thank you.
Mr. Professor, do you have anything to close?
Yes, I think it was an excellent discussion today, and I agree with you, Dimitris, about Helen. She's excellent, really, in her job.
It's very difficult for me. It's very exciting and full of possibilities. But what is hard for me to understand and to design is the connections between the philosophers and the literature. But I can say this, Professor Chatzopoulos and Mr. Vogelis, I have to tell you that it's becoming easier. And anybody out there on Facebook, wherever, who is watching this or listening, I think you can gain a great deal of knowledge, just as I have. I have learned so much from being part of the series. Thank you.
You have made an excellent work. So we thank you very much.
You're very kind.
And now I say good night to everybody and meet again next Saturday.
Okay, good night.
Good night.
Good night. Kalnifta.